Your code just crashed production at 3 a.m. Again, the same memory bug. But what if your compiler could prevent that crash before you even ran the program? In this video, you'll understand why Rust exists and why the world's biggest companies are betting their infrastructure on it. Let me show you. Here's the problem. Every major system crash, every security breach, every late night pager, most of them trace back to one thing: memory bugs. Over 70% of security vulnerabilities in major system code bases are memory safety bugs. In C and C++, you manage memory manually: malloc, free and pray. Miss-free, memory leak, free twice, crash, use after free, security vulnerability. In Java, Python or Go, a garbage collector cleans up for you, but it pauses your program, sometimes for seconds. Rust asks a different question. What if the compiler could enforce memory safety with zero runtime cost? The answer is 3 rules enforced at compile time. Rule 1. Every value has exactly one owner. Rule 2. Ownership moves, never copies by default. Rule 3. Scope equals drop. Values clean themselves up automatically. These 3 rules eliminate double frees, use after free, dangling pointers and data races at compile time with zero runtime cost. That is why Rust powers Firefox, Discord's backend, Cloudflare's edge network, AWS infrastructure, and even the Linux kernel. So here's the deal. Memory bugs crash systems. Rust prevents them at compile time with 3 rules and zero runtime cost. The world's biggest engineering teams trust it. Next up, why Rust has no garbage collector and why that's a feature, not a bug. Stay tuned and subscribe to the channel so you don't miss future videos.